Thank you. Thank you for the invitation. I will be sweating tonight because my tooth of wisdom is sending very strong signals to my brain that you guys, the computer and presentation, is not important. It's something very much important to pain. It's like, sorry for that. I will make some syntactic, semantic mistakes here, but hope you will find something interesting. The other stress I'm having, I don't usually talk to smart scientists. I talk more in a business way, or we explain high level. We do a lot of simplification to allow others to understand what AI does. So there will be a lot of simplification, but we're happy to dive deep in anything what I'm saying and connect you with my really smart people. I'm just the hustler, the CEO, who will explain what we do. But I would love to talk about fashions in AI, how it's changing years to years. So when we were raising our first round 2 years ago here in Silicon Valley, we put a big, very big slide saying no machine learning inside. And we're very proud of that, but turns out that VCs were saying, oh, no, don't do that. So we don't do it anymore. We don't say no deep learning inside, we're smarter. But actually I found this very interesting thing on Reddit. So it's like pattern recognition, the old times, so IQ, you need to only have 110 IQ and small salary. So it's a pleasure to see you all deep learning people with 145 plus IQ earning 500K per year. But really to see that, deep learning is so successful in so many areas that it becomes for many people equal, like AI is deep learning. All AI is deep learning. So I'm happy to present you also different thinking and language understanding, and also the history from that. But let's start with a very short 4 minutes movie I love. You should watch the whole lecture. It's about the future of programming. 4 minutes intro about when something new is coming, how it's perceived by others.
And in the beginning, right, we all programmed in absolute binary. When we coded, it was literally writing numeric codes for each instruction. And that was what we did. That was programming. And then after some years of that, Stan Poley came along, and he invented this thing that he called an assembler. So that was the symbolic optimizing assembly program, this language where you could write in words. If you wanted the computer to add something, you'd write the word add. You could use symbolic variable names instead of hard-coding memory addresses. It was this much more powerful way of thinking about programming. You're much more productive, much fewer errors. Assembly was shown to these guys, the guys coding in binary, and they just weren't interested at all. They just didn't get it. They didn't see any value in doing this stuff. So there can be a lot of resistance to new ways of working that require you to kind of unlearn what you've already learned and think in new ways. And there can even be outright hostility. So Johnny von Neumann, the great scientist who invented the von Neumann computer architecture that we use and so many other things, he said, I don't see why anybody would need anything other than machine code. And one time, so he had a bunch of students, and students were all kind of coding along in binary. And one time, one of his students took a little time out to write his own little assembler so he could write an assembly. And von Neumann was furious at him. Furious that he would waste precious machine time doing the assembly. That was clerical work. That was supposed to be for people, right? And so we saw the same story happen just a little bit later when John Backus and friends came up with this idea that they called Fortran. This so-called high-level language where you could write out your formulas as if you're writing mathematical notation. You could write out loops. And this was shown to the assembly programmers, and once again, they weren't interested. They didn't see any value in that. They just didn't get it. So I want you to keep this in mind as I talk about the 4 big ideas that I'm going to talk about today. That it's easy to think that technology is always getting better because of Moore's law, because the computers are always getting more capable. But ideas that require people to unlearn what they've learned and think in new ways, there's often an enormous amount of resistance.
Okay, so this was the intro, and I believe that every one of you had this resistance in the days of machine learning, deep learning. So let's go to the history. Okay. Let's start with Let's start with the beginning of AI. The idea of an electronic brain, Turing test, or first neural networks in the 50s, and also a new approach to create a thinking machine, so symbolic systems. In the 50s to 70s, we had the first AI boom. And actually, in the 50s, we were saying a fully intelligent machine will be built in less than 20 years. And actually, like every year, we have that in the next 10, 20 years, we have intelligence machines. And we have the first chatbot, Elisa, actually written by psychiatric doctors to emulate the process of psychoanalysis. And first semantic representations were there. Then we have the first AI winter because of overpromise under delivery, the end of funding. And even Marvin Minsky created great criticism of perceptions. So actually it was the end of neural network research at that time. And limited computational power, that was a big problem at that time. And we became first like serious ethical doubts about AI at that time. So you see symbolic thinking, neural network thinking, this also was there and competing with each other 2 years. In the 80s, we have the second AI boom. We were focused on knowledge management systems, new founding, and there was the rise of expert systems. And idea that we can create common sense knowledge by human, encyclopedia, and other thing, and this is the way we hack all AI problems. But then we get into another second artificial intelligence winter, economic bubble, even that DARPA were not like founded, those kind of researchers. Expert systems are so hard to maintain. And actually, David Marr, he rejected completely symbolic approaches at that time. So in the 90s, 2000, they are called by some people the year of shames. So it was shame to work on AI. So people were hiding that I just do something in the largest system of something. And it was really, people were ashamed to be a part of AI. Then we have this beautiful thing like Deep Blue, but it was not a paradigm shift. It was just more computational power. So now we are living in a new era, which statistical AI are the king. So machine learning, deep learning. And here it's also not so easy to talk to you because you're statistical people. Most of people think statistics that way. But let me quote someone who I really admire and is like one of the smartest guy on earth, Peter Norvig. And he said that statistical language models, actually they want everything. Everything is built on statistical language model. This is his famous debate with Chomsky. And what he's saying that actually statistical models, they have not achieved limited success. They are completely dominant and maybe exclusive positions. So nowadays, 2% of people working on this subject don't agree that's on statistical AI. But like the fashions were moving back and forth. So I think we are also on the point that every time that something new will pop up, a new way of thinking. Like a very simple thesis, what do we need to have to understand truly language? Of course, it's the meaning, which is represented by semantic, the structure, syntax, but there needs to be domain expertise and common sense knowledge. These four pieces together create real understanding. So deep learning is great. I had the pleasure of driving a Tesla with an autopilot. This is like amazing what is happening when you experience all the beautiful things what deep learning does. But in language understanding, deep learning mostly serves the meaning part, the meaning part of the equation. And the limitation in language understanding of deep learning, the biggest limitation is data hungriness. Even for a simple classifier, you need to have 100,000 label sets labeled by humans or by other things to create this understanding. And we have this joke in the AI community that people saying that the truck drivers will lose their job because of AI in 10 years. And people saying this is great, we will have more people to annotate data because it's not stopping, it's getting more and more hungry. That's why we're still using machine learning, like less data hungry, but need to work on features. And this is what we believe at Fido. This is the problem, because deep learning is not designed to understand symbolic language. It's a statistical approach, so humans need to train it by examples. And our thinking is that in current AIs, the biggest limits are humans. We cannot scale. We didn't understand even 1% of unstructured data. So when people are annotating the pictures from vacation, cool, we have this corpus. But when you look on healthcare, there is like a desert of labeled information. I believe everyone heard about Google Parse Max Parseface. Who heard about this system? So the new AI of Google is based on this concept. So parser, who is a system which will try to understand what every word role plays in the sentence. So how Parse was built? They took text data, so web data. It took 8 years, thousands of linguists, hundreds of millions of dollars to annotate the data, and then Google used this beautiful deep learning algorithm to create a parser on that. And some people call it the West Coast approach in linguists. So it means let's not care too much about how language works. Let's give more data, more computational power, and we'll figure out. So when Google actually has no limits when you think of money and computational power. But let me show you something interesting. We just get independent benchmarks, which looks on how Parse Max Parseface performs. So it was built 8 years, thousands of linguists, and training on examples. But still, on the part of speech tag level, 36% of all sentences were wrong. Because it's easy to claim scientifically we have 98% accuracy, but it's done on token level, not a sentence. So it means our verbs are understood by 98%. But when it comes to real understanding for application, it's just 36% are wrong. It's a lot. Because in AI, when something is wrong, it's really wrong. So when you build a system to help, for example, restaurant managers understand what they should do to have better clients, it will tell your stinking floor attracts people to you. And my favorite example, when you use Statistical and say, I like wine, the system will learn I'm like wine, because it's more common statistically. So, and the errors are so important here, because when we go to the ages of the models in AI, it's not just a little bit wrong, it's completely wrong about everything. So we will know that you are like Coca-Cola wine people, and like this tweet-up was so great because the speaker was not speaking, was speaking too fast or something like this. So let me show the results on a new approach, which is Symbolic. So it took us 2 years, seven great Symbolic engineers, and the results are the system on a part of speech level create only 7.9% of errors. So it was not done, it's not done in this paradigm of let's train a system of examples, but we use the symbolic approaches actually to teach the computer how language works, not by examples. And we are foreigners. We're coming from Poland, from Europe, and we have this beautiful competitive advantage. Because most scientists are focused how children learn language. And actually, we don't know how they learn language. There are many theories. But we are adults. We learn English from a book. And the book was saying, hey, this is how you form a sentence in English. If you want to do a question, this is how you do it. If you want to express you're afraid of something, you can do it this way. I am afraid of something. And there are actually in English only 9 ways to express what you're afraid of. So we took this old concept of Linguistic, how to teach humans language, and actually coded that into a system, how we would teach adult a foreign language. And I'm really, really happy about this independent benchmark, the results. But this is like, and this allows us to change this thesis of labeling data. Instead of labeling data, we can program a system that understands language, what's important for humans, and actually no human work's acquired after that. So the labeling goes completely offline. And this is another interesting issue as a startup, what we are facing, because nowadays, for example, investors, they have an investment thesis. So AI is very new. They don't know how to look on that. Some people think AI is like an app. So they ask, do you do AI for jogging? Oh, this is cool. Or do you have an app for parking? So AI for parking is cool. And some others develop, investors like this thesis that everyone has the same tools. They're open source. So the only way a startup can succeed is finding a way how they label the data. So when you come and talk with investors and say there is no data labeling, it's also very hard like to move around this thinking. Like I was showing you in the early movie examples, what's the backdraft there. So symbolic approaches, this is the output of Google Maps parse phase. So it's based on dependency, shows us dependencies, etc. So you need to be trained or almost a PhD to understand that. But in symbolic approaches, you can make it much more simpler and give much more information about the language itself. And I'm happy to share links with you and connect after the meetup that you can use and play with this different approach of artificial intelligence.
Is this at the sentence level or discourse level?
So the parser itself works on 3-level structure. So here you see it's 1-level structure, which is great for machine learning, deep learning feed. But we create a structure for humans. So 3-level structure, we have words, phrases, sentences, clauses, which is more like building blocks to play with that, and that humans can use this output of the parser to build chatbots or other application. So nowadays, in language understanding, the king everywhere is classification. So you predefine positive, negative, neutral. You give examples, you train the system, and we say, oh, this was positive, this was neutral. Or you have more classifiers, this is how it is. But we believe, and it's created a beautiful space of great billion-dollar companies, but we believe that the real future of artificial intelligence on language won't be classification, will be information extraction. So you not try to classify information like, oh, he was positive, he is negative, but more like, why? What's happening there? What do you think about things? So let me show you a very simple new framework, how we believe we can extract information. So we take data. So this is an example of, we want to understand by reading reviews of an app, what should we do with the app automatically. So we take the parser, we parse everything, then we use the new programming language, which is very simple, and say so, and how do we extract the information? And in the end, we use deep learning for clustering the results. And then we have the results. So what user ask you to add? They ask us to make the chat opinion auto-rotation. So this is a different framework of thinking. And deep learning has this beautiful place that we get all the information extracted based on rules and thinking. And deep learning do the magic of clustering the information for us. So this is, I want to just introduce you to you the new symbolic thinking AI, that it can substitute humans from the tedious labeling task, and maybe then all the truck drivers can just go for endless vacation, and we live in a good times and not labeling all the data. But well, it's about performance, it's not about telling nice slides and stories. Are you familiar with open information extraction? This is like the 9-year-old idea that we can extract information from any text automatically. So nowadays, when we apply open information extraction, the results on, this is an adverse drug reaction. So the results are 47% precision, 15% recall. This is very, very low. But we can try the same task with new approaches. So we can use dictionaries, part of speech tagging, chunking, normalizations, then a rule-based system, and medical ontology on top. This is how it's done today. But we're getting to 38 precision, 75 recalls, which is very, very low for real usage. And when you open yourself and mix symbolic AIs with statistical AIs, then you can achieve 93% and 60% recall. And this is like what we believe is the future of mixing approaches, of taking different ideas together and mix symbolic with statistical approach to truly understand language. So I'll give you a sneak preview how the language works. So we operate on the logical layer of grammar. So for example, we define predicate as a trigger and object or proposition as the target. And we can apt like object to predicate, related propositional phrase. So this is all like linguistic thinking, but we can code that into the language, because what we understood from the history of language understanding, there are great linguists doing beautiful work for like hundreds of years. And then the computational linguist came, and it's like sometimes not even easy to talk to the linguists because they think so differently. And with this separation, it was like, it's too complicated. Many of these rules, use statistical AI to figure that out. So I remember at Fido, when we started this work, we put one linguist one statistical person, and we gave them only one computer. So they need to agree whatever they write together and try to explain how we can put them more together. I just skipped some slides of the details. And here is the end. So we use deep learning to cluster the results. Here are the side effects, how we can understand them. So in the end, this is information extraction. We have someone who writes about adverse reactions, so we can automatically say, okay, someone changed this drug to this drug because insurance quit paying. And this is simple, the new idea of using a programming language instead of thousands, hundreds of people to label data. But let me show you very briefly something in action, what actually can be done. Patricia, could you help me? So one of our job was to take the all App Store data, ingest that, and automatically answer product development questions. So without reading all the reviews, they need to know what they should add, change in the product. Let's enter Waze. Someone knows Waze as the app? It's a great app. So what the system does here, it took all the reviews and automatically is answered this question. Why user deleted this app? What user asked you to add? What user asked you to make, or what you should do to get higher ratings. So this is what Symbolic AI can automatically extract from text. Let me dive deeper here. So integration with Apple Watch. You will see all the reviews people were writing about this. So for this AI, it doesn't matter how it was written, it understands it. Please add this option. And another use case, so when you can extract information, then you can do magic with that. One is just analytic, but you can start searching in a completely different way. So this is one example we got from one VC recently who was testing our system. He wrote, and people try to do those kind of stuff to show your system's not working. So he wrote, my wife is snoring. And the system could figure out all kind of applications which will help you with a snoring spouse. So this is the idea. When you extract information, you search on the level of knowledge and information and not keywords or links. And this is, and the last super simple example. So we took all the reviews from San Francisco for a client, and they want us to automatically understand what you should bring, what kind of people will be there, what you should avoid, without reading any text. So we process to the Symbolic AI system. Do you have a favorite venue in San Francisco?
Buy Right Ice Cream.
Which one?
Buy Right, B-I-R-I-T-E, ice cream. It's listed as the best ice cream shop in California by Foursquare.
Right Creamery.
Perfect. So let's see what AI thinks about Be Right Creamery. You should explore unique flavors, good ice cream. You should be in a line for a reason. It's recommended for ice cream, to go for ice cream. So let's teach the system something funny now. Okay, yes, there's ice cream. It's not for a hot day. And you should come on weekends, early nights. It's not Polish, but you see that. The vibe is great, cozy. And you will have tourist, hipster-friendly people inside. And you should bring your own pig.
And indecisive people.
Oh, those indecisive people here. And watch out for lines, line down street, and time frame for parking. Someone mentioned parking. And you should avoid coffee in that place, definitely. It's not recommended for your figure.
That's very
So
good.
it actually makes...
Broadway after 11 p.m. Broadway after 11 p.m.
Not sure.
That's where the prostitutes are.
Okay, so you're looking for those kind of experiences. I think I have something here also. Let's look for, Larry Flynn Hustler Club. Boom. So, explore the cloakroom. $2 Tuesdays, funny stories. The vibe is awesome fun, creepy. You will have dancers and good crowd and best lap dancers there. And people is recommended to go for great time, all party people that doesn't want something, to bring female friends who may be iffy about going to strip clubs and avoid food there and wearing a nice shirt. This is the power of information extraction.
Presentation again?
So everyone will face that in scientific and developer life, that you will do something and people will be telling you, oh, it's the 70s, Michael. It's like, this is the old school, this is the part-time. But like, we will see the changes all the time. And so before, neural networks were rejected, and they become king now. And other techniques were rejected, and will be changed, like the history of AI. We will have all different fashions, changes, and everything else. So just very smoothly where we are heading, just to tell you like what we believe that Symbolic Plus can do, that if you want to understand something simple, you will be just saying, hey, show me your actions of deleting, and the system will tell you what was happening inside. So the whole idea is to build more like an operational system that understands language and never teach something by example like an animal. Thank you very much for listening. We are currently fundraising, if you know great investors who think outside the box. So they say, oh, no machine learning side, we don't invest. So we'll be happy to connect. And also we are looking for smart people who want with us to join us and work on the programming language and bleeding the programming language with deep learning. And we hope that we will be able to open the system in 1 year, that everyone can use it, train their data, label the data for deep learning or for any other usage, that AI won't be so human dependent and so data hungry. Thank you very much.